Now you've done all the things. You found an archive, you figured out how to download the data. Maybe you wrote a script, got the data to your machine, you unpacked it. You still got to look at the data to see what the actual format is. If you want to inspect your data, you can use the same tools that I've shown here a little bit already. You can use less to scroll through data dynamically or scroll through the file contents dynamically. Can use head and specify the number of lines from the beginning of the file that you would like. Can use tail and perhaps specify the numbers of lines that you want to get from the end of the file, or cat to just dump the entire contents of the file to the screen. So you do not have to fire up Excel, which people often do for tabulated text files. You can also use other editors. You can use the OpenSARLab editor that is part of JupyterLab. You could use VI or other things. It's very easy to quickly look at files. Many data files have a header section that tells you what the columns are. If the data don't come with it, you need to find documentation. It's pretty difficult to just infer what each column actually means, especially if they're only numeric values. So the general workflow for all of this is that you'll start out with some manual exploration of the archive. You'll test with wget curl scp to figure out how you can get to your data. You've got to come up with some unpacking routine, and then you inspect your data to figure out its format and work on the analysis scripts that now can ingest the data that you downloaded. Throughout all of this, as you're exploring, you should start thinking about generalization. So how can you exploit the structure of the archive to your benefit, and then write a shell script that allows you to automatically download lots of data all at once or in the background from a remote machine. You always want to test this on small but diverse subsets of data. Test it on different time ranges, test it on different stations, different geographic locations. Eventually, it will run the script automatically. It could be part of what is called cron, some kind of timed process that executes scripts for you automatically, or you have it otherwise triggered. This is the general recipe of automating or generalizing your data downloads. You're now equipped with the tools to get tons of data from various places on the internet, either to your Open Science Lab deployment or your local machine. You do not have to go to the URL for each data file that you may have to download. A lot of this can be scripted away, hidden, figured out once, and then executed whenever you need it.